Hello everyone. With our revision of NCERT, we are now taking next chapter to our study, and the chapter is considered to be a difficult chapter precisely because it helps us in understanding entire mechanism of the endogenetic forces. I am talking about origin of the continents and ocean, and restricting us, as I have always been repeating, to the NCERT content. It will actually make us revise three theories, the fundamental three theories on endogenetic forces, namely continent drift theory, plate tectonic theory, and also seafloor spreading. What you need to understand is that whenever we take the revision of or even understanding of these topics are the difficult part, because they create the foundation towards our understanding of why it is so that Japan as a country is much prone to both earthquake and volcanism, or why the mightiest mountains of the world, Himalayas, are though considered to be tallest, youngest, young-fold cordilleras, they are hardly known for volcanoes, though they are quite actively earthquake prone. So we want to understand all of them, and our restriction will be into the NCERT content, which is sufficiently enriching, and it is surely going to help you out with your revision of this chapter, that is on the three theories that complement each other more or less, the three theories of continent drift, seafloor spread, and plate tectonic theory. So let us get to our study of this particular chapter. The chapter that we want to study is the chapter called Distribution of Oceans and Continents. And how exactly we take the study of this chapter, confining us to the content matter that goes with NCERT, is that I need to learn three defined concepts altogether here. Which are they? It is continent drift theory, as I said. And our NCERT overemphasizes on the evidences in favor of continent drift theory. So we'll be talking about that. The second thing that we'll be learning here is of plate tectonic theory. And in the continuity, we'll also be learning seafloor spread. There are certain attachments that goes with each one of them, and these attachments will be learning one by one. I just want to start with the continent drift theory involves the work of a German climatologist, and if we just go here, the continent drift was propounded by Alfred Wegener, the German meteorologist, who put forth the comprehensive argument in form of continent drift. Now, what is important for us to notice as per our NCERT is that I do get mention of some of the earlier scholars who talked about the possibility of fit. So, if I read it sequentially, many scientists thought of the similarity and considered the possibility of two Americas, Europe, Africa, to be once joined together. From the known record, it was Abraham Ortelius, the Dutch map maker, who first proposed such possibility, and the second name comes in from our NCERT, Antonio Pellegrini, who attempted to draw basically the observation of the coastline of Atlantic Ocean is what marks up the beginning of continent drift. And the continent drift that has been correlated with the approach that we identify to have been propounded by Alfred Wegener includes range of evidences that was either supported or outlined by him, and the approaches or evidences that was eventually being taken into consideration. So if I ask you to simply go to this part of your NCERT, it says evidences in support of continent drift theory is number one, matching of the continents, that is called jigsaw fit, and it names Edward Bullard, because continent drift theory was as a research paper published in 1912, and as a complete text is dating back to 1915. So the work of Alfred Wegener is the beginning of 20th century, and Bullard could give us this in 1964, so second half of 20th century. Then evidence number two that talks about rocks of the same age across the ocean. And if I continue with my NCERT content, the other evidences which are being mentioned before we take support of diagrams to understand it includes. Evidence number 3 mentioned in our NCERT is stilite, which is sedimentary rock. I have already uploaded a video on rock type, so you can take reference of it. The sedimentary rocks formed out of deposits of glacier, and these are being identified in southern continents. All the base, the system was thick tillite, indicating extensive and prolonged glaciation. Counterpart of this succession is found in Africa, Falkland Island, Madagascar, Antarctica and Australia besides India. So it is basically the glacial tillites which is giving us what is called paleoclimatic evidence. You can also call it evidence of glaciation. And then the NCERT also mentioned 2 more evidences, if I just highlight it. Number 4 is placer deposit. The gold bearing veins are in Brazil, and it's obvious that gold deposit of Ghana are derived from Brazil plateau when the 2 continents were lying side by side. Placer basically goes with, like we have taken sea waves in our study, in our last video, movement of ocean water sea waves. So if I say that I as any agent, I can be river and I am breaking the mountains. So breaking the mountains, I will be eventually depositing broken rock material that is called debris. And rocks actually are made up of minerals. So my deposition will be mineral deposits also away from the source, and such deposits are called placer deposit. So placer deposit will include exogenetic factors. So placer deposit can be river deposit, placer deposit can be glacial deposit, placer deposit can be sea wave deposit, it can be any. So placer deposit says that the gold bearing veins are in Brazil, but I find the deposit in Ghana. So if I apply my logic of map, it very clearly says that they possibly would have been together. And the 5th evidence that is being given in NCERT is the distribution of fossils. And distribution of fossils, we have got a big references of different organisms. And this was the question that I asked in the earliest test that we had. Observation that lemurs occur in India, Madagascar, Africa. Considered the contiguous landmass called Lemuria. And this Lemuria basically gives me the understanding that possibly all these continents were united once upon a time. So taking this first part from NCERT, let us take the diagrams to understand how to go about with the learning of, with the orientation of continent drift theory of Alfred Wegener. Now, as I said, it was in 1912 that a research paper was being published by German climatologist Alfred Wegener, Origin of the Continents, and it was eventually enlarged as a complete text, Origin of the Continents and Oceans. And in this he talked about, and I am zooming in, that there existed a supercontinent called Pangaea. We can notice Pangaea here, which actually is combining all the other continents and recognizable with their shape. This is my Eurasia, this is North America, South America, Africa. I can notice this part as including Arabia and India, so I am labeling it as India, and this will be Antarctica. And the super ocean was being given the name Panthalassa. And the propounder identified that some 225–300 million years ago, Pangaea, the supercontinent, existed. This supercontinent eventually disintegrated into, some 150 million years ago, this supercontinent called Pangaea got disintegrated into Laurasia. We also call it Angara land, the northern landmass, and Gondwana land, the southern landmass. So Panthalassa water intruded in, and this marked the development of the erstwhile Teth Sea. Panthalassa marked up its division. And the continuous disintegration thereafter, so we jump to 100 million years old history, which is diagram number 3 here, and we can see that there is a clear demarcation of the more recognizable present type of map, in sense that Southern Ocean, shading it here like this, development of Indian Ocean here, development of Atlantic Ocean here, and the closing down of Teth Sea here, because Africa, India, Arabia all moved to buckle up with Asia like this. So 100 million years ago we had recognizable other oceans of the world, and Earth today is how we recognize it. So you can notice, and I am just putting on some red shades to it, South America, North America parted away. South America, which was part of figure number 3, South America, which was part of Africa, have parted away, creating Atlantic Ocean. Africa not just parted away from South Africa, America, it moved to buckle up with Europe. Arabia, India detached from Africa and marked up their buckling up with Eurasia. Antarctica in South Pole and Australia here. So Southern Ocean, Indian Ocean, Atlantic Ocean automatically resulted into contraction of Panthalassa. So Pacific Ocean, the largest ocean of the world, makes the example of contracted Panthalassa. What was the reason that we take continent drift theory, that too propounded by a climatologist, as our step 1 in the learning of what is called as origin or development of the continents and oceanic crust, is that most of the things that have been approached by Wegener have proved to be correct. And focusing on what our NCERT says, let us take quick revision of: there existed a supercontinent Pangaea surrounded by superocean Panthalassa, got divided into Angara land and Gondwana land with Teth Sea. The subsequent division led to the genesis of other oceans, and came Pacific Ocean as contracted Panthalassa with other oceans of the world. And as soon as I take this approach, does it sound convincing? Oldest oceanic crust has to be with Pacific. Rest all the oceans are comparatively newer crust. And I'll be talking about it one more time as I'll talk about seafloor spread. So once existed Pangaea, it got disintegrated into 2 and then 3 to develop the present day map of world as put forth by the German climatologist Alfred Wegener. The continent drift theory is considered to be the concept that gives us range of evidences, which we have already seen with our NCERT. And if I ask you to take the further well demarcated labeling of it, so we are demarcating the labeling or the evidences. So read here, the evidences for continent drift includes, and we are including what? Number 1, the continent edges are fitting like puzzle pieces, and this is what is called jigsaw fit. So I can see fit of shape. Evidence number 1. Evidence number 2 includes same fossil. Same fossils found on different continents. So I can find it as fit of fossils. Then comes climate. The climatic ice sheet, as I said in NCERT page, we can call it paleoclimatic similarity. And finally, it includes rock structure. So 3 and 4. And what is this rock structure that we are having? Mountains with similar features, like we can have fold mountains, which is largely applied in north. We have got the rifts that are being created in south. So it is all about the tectonic features. So there are 4 levels of evidences that we are willing to take in reference to the evidence of continent drift. as our step 1 in understanding the genesis of the continents and their present distribution. The evidence number 1 reads fit of shape, and this is best seen, and that is the reason I have selected this image. It is best seen in South Atlantic shoreline, where we can notice that almost the entire length of shoreline, we are noticing fit of shape between Africa and South America. And as our NCERT reads, it was Sir Edward Bullard who in 1964, with the use of computers, identified that this fit actually is not just by chance. This fit actually belongs to almost entire shoreline, and the shoreline with also the depth that can be up to 1000 meters. So it's a range that we can take actually, but the maximum depth that I am noticing fit of shape not just in the entire shoreline, but I am also noticing this fit to be up to 1000 meters. However, yes, there are certain unconformities. And what are these unconformities? That is, if I break two entities that once upon a time were together and then I try to rejoin them, will it not be that the fit will not be cent%? Reason? Because of mutual wear tear. Similarly, I was developing the ocean and there will be erosional modification of my shoreline. And today when I take the river action in these areas, I can easily apply them as right here, we have got river Sao Francisco. And in this location we have got river Niger. So the third reason of prevailing unconformity can be the river deposits. So yes, this fit of shape, evidence number 1, best seen in the southern part, is not just the by chance kind of a fit. It incorporates such convincing evidences that it becomes logical for us to understand that yes, this evidence is something which is very real. However, when propounded by a scholar in 1912, these details were not there. And once we take these river Niger and river Sao Francisco river deposit, or erosional change in the shoreline by sea waves, or certain mutual wear tear because of the breaking, we are convinced that if these two continents once upon a time were together and today they are not, so automatically it is that continents have drifted, and this is the evidence of continent drift, evidence number 1. Okay, coming to evidence number 2, and evidence number 2 is the fossil evidences or fit of the fossil. What is very interesting is that if I take example of one of the fossil, and that is the reason I have selected this particular image, I want you to see this green shade, and I am just helping you out to notice it with additional shade. So are we noticing that South America, Africa, this is Madagascar here, India, Antarctica and Australia, all of them have got the presence of fossils of fern. Fossil of fern called, I am slightly zooming it up here, fossil of fern called Glossopteris. Fossil of fern found in maximum of the southern continent. Why can be the example of concern? Because we need to understand that during the time, because we are talking about Gondwana land to be existing since say 300 million years ago, and by that time we were not having, birds were not, I am writing it here, birds were not evolved. So the fern of or fossil of the fern by default, if it's present in all such continent pieces, it gives me a logic that truly they were combined together. And it is not just one. I have got many more examples, though they become restrictive. So if I ask you to see the another shade, fossil of Triassic land reptile right here. And this shade that has been given to it. Land reptile was having a restrictive present compared to the fern fossil. And if it is that land reptile is marking its presence in Africa and then India and then Antarctica, what else I can say? That they were combined. Another land reptile mentioned here have got its presence, its fossils, and mind it, they are land reptile in South America and Africa. And mentioned dominantly in our NCERT is this Mesosaurus. Fossil remain of the freshwater reptile, and this freshwater reptile has got least extensive area, but this is freshwater reptile. So if I take these evidences in front of me, I have got the fossil evidence of Triassic land reptile. I have got evidence of Triassic land reptile 2, freshwater reptile, and also the fossil of the fern. All these are giving me examples to prove that these continents were once upon a time combined, and if they were combined, continents have drifted. Evidence number 2 in favor of continent drift theory thus goes as fossil evidences. And what is fossil evidences? Fossil evidences includes fern, land reptiles, freshwater reptiles, and also a range of other specimens, proving that these were combined once upon a time, today they are not. So evidence number 2 in favor of continent drift theory, fossil evidence. Now we are talking about evidence number 3. And what is evidence number 3? It is called apparent climatic polar wandering. And NCERT specifically mentioned, which I have asked you to see. The sedimentary rocks formed out of deposits of glacier. Now, if you try to see them, you will easily understand what I am actually asking you to interpret. So, all these land masses, I am talking about Australia, I am talking about India, and notice we are taking the southern part of Africa altogether right here, and part of Brazil and Argentina. Argentina still can be considered to be an higher latitudinal country, rest of them are not. So, if we pick up the evidence of glaciation, what exactly it gives us? Together, land masses like India, Australia with Antarctica and countries of South America along with Africa experienced ice cover together. And these ice cover together is not just proved by the deposits of tillites, the sedimentary rocks that are deposited as glacial deposits, but also what is called striation marks. And striation mark can be seen as the movement of the arrows that you can see in this diagram. Movement of glacier tends to demarcate the point of what is called scooping, the plucking effect that is generating the evidence of its movement. So, if we experienced ice cover together, in spite of the fact that we are not together and we all are almost located in the lower latitude where such ice cover is not possible, then what exactly is the reason that we have experienced it together is additional evidence that we were once upon a time together right there at the south polar location. So, if I have to slightly explain it further, I will say Gondwana land drifted from south polar location to divided present position of land masses. Now this is called apparent shift of south polar climatic condition. Apparent. You can call it apparent polar wandering, which I wrote earlier. Either ways, you refer it as apparent polar wandering, you refer it as prevalence of Gondwana land, you pick it up as striation mark, you pick it up as sedimentary rock deposit called tillites, all of them. All of them actually combine to give me what? It gives me the understanding that there existed Gondwana land and continents thus have drifted. Evidence number 3. The evidence number 4 goes with the reference of rocks of the same age along with the similar type of mountains. Now carefully take note of this particular diagram. The Appalachians, West African mountains, mountains in Greenland, British Isles, Newfoundland and Scandinavia. These all are called Caledonian mountains, old mountains. They all make example of same rocks or geology with similar formation process, as in the mountain Appalachian range extends as Newfoundland and then to Ireland and British Isles to Jolan Mountain. So if I take Appalachian, which is mentioned here, Appalachian mountains continues as Pennines Mountains of British Isles and Jolan Mountains of Scandinavia. How it will be possible that across Atlantic Ocean we are having same type of mountains? It is essentially because the continents were once upon a time united. A slightly complicated image, have a look on it, it will be much more evident thereby. Are we noticing? Caledonian mountains were found on both the sides of Atlantic. This is what we labeled. And this is my central Pangean mountain. Don't miss to see, it is North America including northern part of Africa. And it reads present day Little Atlas Mountain of Morocco. Noticing it? So what exactly is the point that we say, no, these mountains have got their similarity in terms of their rocks, in terms of their geology, because they were formed together. And we have already talked about fossils, so you can see that repetitive account. We have talked about this. I hope you are recognizing this will go with the fossil fern. All these basically combines. So going back to the image, see this carefully. Don't miss to notice Paleothecocean. This will be Panthalassa. Can we make sense now? So here we have got the Atlas Mountains, which are being mobilized as young fold. Appalachians, Pennines Mountain, Grampian Mountains, all are old mountains, and so are Jolan. And it is not just when I say same rocks and geology, I am actually talking about coal beds, I am talking about ferrous mineral resources, I am also talking about limestone availability to them. So they give me the similarity of their structure also, proving that they were together once upon a time. And that is how we take evidence as evidence number 4, that these land masses once upon a time were together in reference to what? Similar types of rocks and similar types of mountain development. Evidences of continent drift theory includes fit of shape, fit of fossil, paleoclimatic, rock and mountain system. Wegener gave us development of present position of continents, ocean, without any doubt. So this is the contribution. But what made continents drift? Was not given to us clearly by the scholar. So in the absence of clear mechanism, we have a changeover mentioned in our NCERT, which talks about post-drift studies and how it is that the forces of driving can be taken. So I take this statement of mine, what makes continent drift? I take you to NCERT again. The forces for drifting. Wegener suggested that the movement responsible for drifting of the continents was caused by pole fleeing force and tidal force. The pole, I am numbering it, the pole fleeing force relates to the rotation of the earth. We are aware of the fact that earth is not a perfect sphere. It has a bulge at equator. This bulge is due to the rotation of the earth. And this rotation of the earth results into what? As earth is spinning on its axis, this is my earth, and earth is spinning on its axis west to east. It tends to make every surface feature move towards equator. And that moving towards equator resulted into the Gondwana land constituent move towards equator, Angara land constituent move towards equator, developing the present landmass. The present landmass which is combined as Africa, Eurasia. So Africa, Eurasia in the present day map is outcome of force number 1, that is pole fleeing force. And then he talks about second force, that is tidal force. The tidal force that is caused by attraction of moon and sun, we learned it in the last video, believed that these forces would become effective when applied over millions of years and will facilitate the movement towards west. So the movement towards west resulted into what? North and South Americas drifted towards west, which resulted into what? Contraction of Panthalassa, and added to it creation of Atlantic Ocean. Forces of drifting has been applied by Wegener like this. But is it this that facilitates the movement of the continents? We have to actually, scientifically, it is incorrect. I cannot apply these to be the forces of drifting. So what are the forces of drifting? From NCERT, convectional current theory. Arthur Holmes discussed this. What is convectional current theory? It is also called mantle convection. What is it? Let us take support of this diagram. Can we notice this? The topmost layer of the earth is called lithosphere, and lithosphere is 100 kilometers from the earth's surface, and lithosphere shading it like this. We talked about it in our study earlier. And then we have got mantle, the second prominent layer in the earth's interiors. lithosphere, the top 100 kilometers of Earth's surface, which moves over mantle. Upper part of mantle is called asthenosphere, that extends up to 400 kilometers of depth. And these red arrows that we are noticing in mantle is called mantle convection. Or convective magma movement. It is in the influence of this mantle convection that lithosphere move apart from each other or converge with the development of subduction. So what facilitates lithospheric floatage over asthenosphere? What exactly is the driving mechanism? The driving mechanism is mantle convection. It is not the pole fleeing force and it is not the tidal force. It is lithosphere floating over asthenosphere. Continent drift theory created the base on the reference of which the driving mechanism was being contributed by Arthur Holmes, which in combination to, I have not talked about it, seafloor spread, gave us plate tectonic theory. Now concentrate on this map of world which talks about plates. Plates are defined to be, what are plates? Plates are divides of lithosphere that move over asthenosphere in the effect of mantle convection. As of today, we recognize 7 major lithospheric plates: North American plate, South American plate, African plate, Eurasian plate, Indo-Austral plate, Antarctic plate, and Pacific plate. Barring the exception of these 7 major plates, so 7 are major. You must be noticing this map looks different because I am not highlighting the shoreline, I am highlighting the boundaries of the plate. All the other names, I am lightly shading them: Juan de Fuca, Cocos plate, Caribbean plate, Nazca plate, Scotia plate, Arabian plate, Indian plate, Philippines plate. Noticing them? They all are called minor plates. So basically, lithosphere is divided into several pieces. These pieces are called plates. On map of world, there are 7 major plates today and there are many minor plates. All these plates move in relation to each other and tends to develop the boundaries, and it is these boundaries where we develop different types of endogenetic forces. So how do I take the demarcation of volcanism or earthquake? It is always at the boundaries. So what is the benefit that I get from plate tectonic theory is plates moving in relation to each other develops boundaries. And at boundaries, you will have earthquake, volcanism, and mountain building. So all these lines that you are noticing, are you noticing this? Now this is running along mid-Atlantic ridge and this forms the boundary between North American plate and Eurasian plate, and African plate actually is incorporating, carefully note, Indian Ocean also. So this is African plate, this is South American plate, minor plate is counted within, this is North American plate. I hope we are noticing the boundary. This is my Pacific plate, Nazca will be its part. This is my Antarctic plate which we have already demarcated. This is my Indian Himalayas, south of Indonesia, Indo-Austral plate, and Pacific plate boundary, Philippines included right here, and this is my Eurasian plate. So all the highlighted black is where we'll be having our endogenetic forces. So it develops boundaries. What are boundaries? Under the effect of mantle convection, when lithospheric plate diverges, it tends to develop spreading center. This spreading center is oceanic ridge. When it comes in convergence to, so I have got this convergence, I have got this convergence. If I concentrate on this convergence right here, this is my continental crust. So this convergence will result into subduction, I hope you are recalling. This will create trench and active volcanic location in the continental crust. So there is subduction here. Subduction will create trench. And right here, can we notice that the mantle convection is facilitating continents convergence. So if I just try to make this as convergence, inactive boundary, collision between the two continents results into what? Notice this. Himalayas are at colliding boundary. Rockies are at destructive boundary. What is the difference? Difference is, if converging boundary is colliding, it is distinguished from converging boundary that is destructive. As in both the case, I will be developing fold mountains, but the fold mountain at destructive boundary will have volcanoes, and the fold mountain with colliding boundary will have no volcanism. Collision boundary between continent and subduction zone with volcanism. Without the curvature, rising magma, asthenosphere, diverging plates, oceanic crust, mid ridges, subduction, continental crust, ocean subduction, it develops rollback. Mind it, this is the subduction which is oceanic continental, and this part subduction is oceanic. And that is the reason it tends to develop what? This is also ocean and this is also oceanic crust. So the rolling back, the subduction rolling back results into the development of these volcanic arcs. And that is what I mentioned in the last video called festoons. This is my trench and this is also trench. And don't miss to see this. transform boundary. We are moving in the same direction, but at differential rates. So this divergence has created what? It has created the ridge. So we have understood the divergence has created the ridge. But we are moving, say we both are moving towards our east, and our rate of movement is different. So there will be break that I will be developing in between, that is called transform fault. So transform boundary can be noticed perpendicular to the ridges. Boundaries converging colliding, destructive, transform, divergent. And to see oceanic divergence, let us notice this. Two continental crusts are spreading apart. This has resulted into rift valley creation. Can we notice rift valley here? The continuous moving apart have resulted into the horsed and graben topography. Are you noticing this? So this rift valley have got enlarged, and there is the development of oceanic basin as Red Sea. I talked about Red Sea earlier. And if this continues to diverge further, it will generate a full-fledged ocean, and that ocean is what we have, Atlantic Ocean today, that has got a rifting in between now. So this is what is mid-Atlantic ridge, and this is my basin of Atlantic on either side. This is my west coast of Africa, this is my east coast of America, and I am largely not having any active boundaries here. So when the two continent crust starts parting away, so this can actually be taken as example of Somalia parting away from Africa. So this is presently, this can be the case. And this is Red Sea, where Red Sea is right there. Which continental crust? This is my Arabian plate, and this is my African plate. And the third stage of its development, so I am talking about divergence actually. Third stage of development, I create a full-fledged Atlantic ridge, which was a previous rift valley. So this is how the diverging boundary can mark up its development, and most of the ridges develops this way. And who exactly gave us this? It was Harry Hess. Harry Hess propounded the concept of seafloor spreading. And what is seafloor spreading? We have just talked about it. He talks about seafloor spreading with this point also. At spreading boundary, new ridge will get constructed, and at converging boundary, old will get destructed. So new construction, and I hope you are recalling, we are talking about subduction. Old destructed. So this is new construction ridge. Active divergence is taking place here from asthenosphere. Magma is rising up. At subduction, old crust is getting destructed. Why conveyor belt? Oldest oceanic rocks are not older than 200 million years ago, whereas continental rocks can be 4,000 million years ago. Remind yourself, oceanic crust is denser, basaltic, and thus subduces. So Harry Hess seafloor spread gives us conveyor belt concept. Conveyor belt concept says new construction ridge and old destructed at trench. So you have to take that combination to understand why the oldest oceanic rock is not older than 200 million. The concept of seafloor spread is excellently supported by zebra strips. The scholars like Wine and Matthews. What does this stands for? Carefully see, slightly zooming it in. This is where magma is rising, and this pair of rock shown as blue right here will be the youngest pair of rock. As I'll be increasing the distance from the rising magma, the age of the rocks will go on decreasing. So you don't need to remember these names, but carefully notice, and I can add one more name actually with it. 5 million years of seafloor mapping has been done, which gives us the understanding that with increasing distance from main boundary, age of rocks increases, and there is magnetic anomaly with them. And this magnetic anomaly, why is called zebra strip? Because I see alternative bands of the blue color that you are noticing here is about positive. So it is normal, this is reverse, this is normal. So you have to take this as zebra strip. How do I apply this zebra strip concept altogether? It is that for last 5 million years we have recognized at least 4 major categories of reverse and normal. As I said, I don't need to remember the names, but just for the reference sake, Bruns normal, Matuyama reversal, Gauss normal, and Gilbert reverse is what has been applied by scholars. So if you have to understand it, what exactly is the point that I need to interpret? I need to interpret that I am increasing, there is continuous spreading of the sea floor, which is resulting into the development of new ejection of magma and its solidification. So with increasing distance, the age of the rocks increase, goes very common and convincing. What is this concept of magnetic anomaly or zebra strip? Understand it with this. Earth acts as a bar magnet, and this bar magnet is with iron rich interiors, and this iron rich interiors is molten and has got spinning like a dynamo, changing magnetic polarity in regular periodicity. So can we notice that diagram number 1 is showing me normal polarity, that is Earth's magnetic north and geographical north are together, and reverse polarity is when we are having that as opposite. Now if there is a continuous spreading that is taking place and there is the development of paired rocks, so it is involving time. So as and how I keep on increasing the distance from the area of divergence. I am drawing some paired rocks and I will just be numbering them, right. So, I have taken this pair 1, then I have paired 2, then I have paired 3. So, will it not be that 3 will be the oldest rock along the spreading boundary and 1 will be the youngest rock? And also, because young is getting developed now, magma is rising right here, what will happen? It will have normal polarity, polarity that is as of today. And if I go with the others, older rocks, there will be the development of anomaly. See this again. Normal polarity, reverse polarity, normal polarity. Noticing it? Mapping of seafloor is also related to the magnetic polarity mentioned in our NCERT, and you should be aware of it. And which are the polarity that we have actually mapped? Bruns normal, Matuyama reverse, Gauss normal, and Gilbert reverse. 5 million years old, present. When I talk about contribution of Harry Hess in the study of seafloor, he is the scholar who has given us Hotspot. I talked about it earlier. I just want you to see this image one more time. Seafloor moving over mantle plume. This is my mean sea level, will develop what I'll call this? This will be, right? Hotspot volcano is additional type of active volcano. When we take movement of plate, this is the plate movement shown here over the mantle plume. And the best example for this is actually south of Hawaiian Island. There is a new island which is getting formed. It's called Lohi. And right here we have got Mount Mauna Loa. And this is the plate movement. And if I go older than this, we have got Emperor Seamount. So what has happened to Emperor Seamount? It has got eroded. It is Seamount now. And these are all Hawaiian Island are. And this will be oldest, and this is what is getting developed now. So, getting developed, it is largely missing in most of our school atlases. So, Harry Hess's contribution is conveyor belt and hotspot. I hope you have understood the chapter that we have discussed. I surely want to complete this particular video with a very humble request, a very humble guideline, if I can call it so. We are in uncertain times, we all are aware of it. We are not very sure what is going to be the scenario after the lockdown period is over. Prelims is, I'll not say round the corner any further, because we know that there is the uncertain, there is the haze which is right there in front of us. But the best thing that is there in our hand is to consistently prepare, and prepare with the sources that we have with our own availability. Moving out by default is not advisable. That is the reason, simply sit at home, remain safe, consistently keep on preparing, don't linger it on, because if we are eyeing 2020 prelims, sooner or later it has to happen. Date as announced by UPSC is not being changed as yet, but as I said, we are in uncertain time. The things can take a better turn or can go other way around. Optimism is the only way that we can help ourselves in this time of crisis. And as our Prime Minister also said, Jaan hai to jahan hai. So just take good care of your health, be safe, prepare, don't waste this precious time as you are right there locked in your homes. I hope all of you are there with your families now. Support each other and do utilize this time while revising. So happy learning to all of you and all the very best.